Welcome to part 5 of Exam 1 review for Math 1813, which is prep for calc. Let's go ahead and just hop right in. So we're starting with section 2.3, transformations. If you want to look at anything before, check out parts 1, 2, 3, and 4. Alrighty, so number 36 says a function f has domain -20 to 15, range -1 to 12, and the point -5, 7 lies on its graph. The function h is a transformation of f given by h of x equals 3 times f of 5 by x plus 6, all of that plus 2. So it says here, describe the transformations in any correct order. So essentially what that means is you would do the shifts and compressions first, and then the vertical or horizontal shifts, or you would do the horizontal compressions or the vertical compressions and stretches first before you would do the vertical and horizontal shifts. So I'm going to do the horizontal stuff first, and then I will do the vertical stuff. So we'll do the horizontal stuff first, and then I will do the vertical stuff second. So for horizontal, we have horizontal is what happens to the x. So right here inside the f of, this f of function, we can see what happens to the x. So it looks like we have some sort of shifting, and we have some sort of compression, right? And so if you remember, whenever we're talking about horizontal, this 5 here, you take the inverse of it to find what the factor is of compression. So we have a 1/5 factor of compression, or you could also say something like horizontal compression by a factor of, and then just remember it's the reciprocal, so 1/5. Okay, and then the next thing happening to the x, or in the horizontal direction, is this 6 here, right? And if we remember correctly, that sign is also switched, so it's not moving in the plus 6 direction, it's moving 6 units in the to the left. So it is a horizontal shift 6 units left. Alrighty, so let's go ahead and do the vertical stuff. So vertical, we have 2 things happening in the vertical direction. It looks like this stretch factor there and this shift here. And remember, you do these stretches and compressions, the stretches and compressions before you do the shifts. So this has a vertical stretch by a factor of 3, and in this case it does stay that number, it's not reciprocal or anything. And then we have a vertical shift 2 units, and then this is also in the direction of the sign, so 2 units up. Alrighty, what are the domain and range of h? So we did change a few things to our f of x function, right? So we had f of x with a domain of, we had an f of x function with a domain of -20 to 15, and then we had a range of -1, 12, right? So then in order to find the new domain and range, you remember that what's happening to the horizontal is in the x direction, and what's happening to the vertical is in the y direction here, right? So the domain has to do with the x, and the range has to do with the y, so we do those things. So the domain is being compressed by a factor of 1/5. So we're going to take our new domain, and we're going to compress everything in our new domain by a factor of 1/5, and then we're going to shift 6 units to the left. So we're going to shift 6 units to the left, like so. Okay, and then our next one is 15 by a factor of 1/5, and we're shifting 6 units to the left as well. Now you might be wondering why we're subtracting here and not adding. This subtraction and addition has nothing to do with this up here. So this in the domain does follow exactly what you would see on a graph. So if you're shifting 6 units left, you're subtracting 6. So our new domain is this negative 20 by 1/5 is negative 4 minus 6. And then this is 3 minus 6. So our new domain is negative 10 and negative 3. Okay, so a range will be the same way essentially. So range in the y direction, so we're going to be looking at the vertical stuff. Our range was negative 1 and to 12. So negative 1 by a factor of 3, and then shifted 2 units up. And then our 12 by a factor of 3, shifted 2 units up as well. So then it is negative 3 plus 2 and 36 plus 2, which means it will be negative 1, 38. Alrighty, so now moving on to C, it says name one point that must lie on the graph of H. So if we have h of x is equal to 3 times function 5 times x plus 6 plus 2. And then we also know that from f of x, or we know, let me write this a little differently. We know that f of negative 5 is 7. So if you notice, this f chunk here looks something like this, right? We just have a bunch of extra stuff in the parentheses here. So what we could do is we could just call this entire thing 7. And let me not lose y'all. So essentially it's like saying f of some new variable is 7. So then that means that everything on the inside is going to equal this negative 5. So something like negative 5 is equal to everything that's on the inside. So 5 times x plus 6, right? So now that we have that, we would have, say we divide it by 5. This is just straight algebra right here, negative 1, x plus 6, minus 6, minus 6, x equals negative 7, right? And then just to double check, this x equals negative 7, does that fit in our domain? Our domain was negative 10 to negative 3, and negative 7 falls nicely in there. So yes, it does fit our domain. So just double check that, make sure everything is lining up and makes sense. So now that we have that, we found our x. Well, if we go back to this function, and we have h of x equals 3 f of 5, negative 7 plus 6 plus 2, right? I just plugged this into the x. That's all I did. And now we have h of x is equal to, so we have h of negative 7, right? H of negative 7 is equal to 3. And now we have some f of chunk. So remember f of, and that all ends up being negative 5 plus 2. And then if you remember from our point here, f of negative 5 is 7. So this f of negative 5 here goes to 7. So now we have h of negative 7 is equal to 3 times that 7 plus 2, which gives us h of negative 7, is equal to 23. So this means if the h is not as nice to look at, this is also our y point. So then our point xy is equal to negative 7, positive 23. Right? All right, so let's move on to the next page. Alrighty, so now number 37 states, a transformation takes the function of f and creates a new function given by the formulas in column 1. So essentially these are all some sort of transformation, right? And it says assume the point 12, negative 6 lies on the graph. So we have a point 12, negative 6, just to start everything off. Match the formula 1 to a correct interpretation 2. So we have to match this formula to what it means down here. And the coordinates of a point on a new graph. So let's start with the very, very first one. So I'll make sure to have both in the screen. So this is the first one. G of x is equal to f of 3x. So remember from the last page, if something is being multiplied to the x value, it's essentially a horizontal stretch or compression. And remember, it's the reciprocal of it. So this right here is actually a horizontal compression of a factor of 1/3. And if we notice, that is this lovely little thing down here. All right, so it's a horizontal compression of 1/3. So then that means that our letter up here would be G, and now we want to find the coordinates. So the horizontal compression by factor 3 only happens to the x, right? So if we have a negative 12, 6, and I'll do the workout here. If we have 12, negative 6, and we want this x to change by a compression of factor 1/3, then we just take that, and that will be our new point. So our new point is 4, negative 6, right? Because 12 times 1/3 is just 4. All right, so the next one states h of x is equal to 3 times f of x. So this just means the opposite of what the first one meant. So this is of a vertical stretch by a factor of 3, which means, and we don't have vertical stretch by a factor of 3, so this also means that the y coordinates will be multiplied by 3, unlike the first one where the x coordinates were multiplied. So if we see, that's this right here, multiply the y coordinates by 3. So that means that our answer for the second one is B. And so if we multiply our y coordinates, so we're chilling at we're restarting, right? So we have a 12, negative 6, and I'm going to write a little, split it. And now we're multiplying the y coordinates, right? So this is now 12, negative 6 by a factor of 3. So now our new point will be 12, negative 18, correct? Okay, so then the next one states Ix is equal to f of x minus 3. So this is a horizontal shift of some sort. And if we remember, the signs are opposite. So this is a horizontal shift in the right direction. So we're moving our units to the right, which also means that we'll be adding 3 to our x coordinates. So I see that this right here states that we are shifting our units 3. We're shifting our x 3 units to the right. So then when we switch over, so then that would be an f. When we do this up here, we have 12, negative 6, and we're shifting our x's 3 units to the right, so we're adding 3 units. We have 12 plus 3, negative 6, so then that would just be 15 to negative 6, just like that. Alrighty, now j of x says f of x minus 3. So this is a vertical shift, and this one does follow the sign convention. So if you're subtracting 3, you are moving down. So we're moving our y coordinates down, or we're subtracting 3 from our y coordinates. So it looks like H is that answer. Shift down 3 units. So that's H. And if we want to do that, what that would look like would be 12, -6. And we're shifting this. So now we have 12, -6 minus 3, which is now 12, -9. All right, next one says k of x is equal to f of x plus 3. So this is the same thing as the I right here, but with a different sign. So instead of adding 3, instead of shifting right 3, we are going to be shifting left 3 and subtracting 3. So that means that our answer is this A right here. And we're going to be doing the opposite of what we did up there. So instead of adding to our x, we're going to be subtracting from our x. So we have 12 minus 3, -6, and that will give us 9, -6. Alrighty, and the last one says L of x is equal to f of x plus 3. So again, this is like this one up here. Didn't mean to write on that one. So this is like this one up here, but it's in the opposite direction. So we are going to be adding 3 units to our y coordinates, or we're going to be shifting our y up. We're going to be shifting vertically. And that means that it is E. Add 3 to our y coordinates. So E here, and then again, if we have 12, -6, and we're going to be adding 3 to our y, that'd be -6 plus 3. That gives us 12, -3. Alrighty. So now it says 38. A function g is a transformation of f of x equals square root of x. Its formula is given by g of x equals 3 f of -x minus 2 minus 1. Write a formula for g of x in terms of the square root function. All right, so let's do that real quick. Okay, so I'm going to just separate out a few things just to keep everything in track. So we know these two things. We know f of x. Oh. Okay. We know f of x is equal to square root of x. And then we know g of x is equal to 3 f of -x plus minus 2. Minus 1. So if we notice, this is similar to this, so we just are going to change this value with what is in here. Okay, so then that means that we've got g of x is equal to 3, and I'm going to put this in brackets, -x minus 2, in brackets, minus 1, right? And that's essentially it, but you can simplify what's on the inside. So you'll have g of x is equal to 3 root -x plus 2. So I just pulled out a negative, but that minus 1 still stays outside. So either one of those answers is the correct answer, just like that. Alrighty, so on to number 39. It says find a formula for the function g as a transformation of the function f. So this is our original, and I'm just going to write that to keep everything in track. So this is our original, and this is our new function. So we want to figure out how f of x turns into g of x, right? So what I like to do with these, I like to look at the graph first. So I could say that this point shifted up to this point, but to be honest, it didn't, because this point here, if it would have shifted up here, then that means this point would shift here, which is not true. This point shifts here, right? So I can tell it's some sort of stretch or some sort of compression. It looks like it's a horizontal compression and a vertical stretch. At least that's what I'm saying. So let's go ahead and try and figure out what the factors of that are. So I'm going to actually take from my f of x my 2 points that are given. So it looks like my points are 0, 1, and 8, 1. Right? And then our points from g of x are these 2 points, which look like, oh, not 4, looks like 0, 4, and 4, 4, right? So if we notice, just from looking at this, these 2 points here, only the y value changes, right? and the y value changes by a factor of 4 is what it looks like, right? And x does not change because it is 0. So if the y value changes by a factor of 4, that means that our function is something probably like 4, our g of x function is for f of x, right? But we're still missing something here. And the only reason I'm going to say that is because if we look at our second point, if we were to simply say that the 1 to 4 changes, that's correct, right? So let me circle that. So this 1 and this 4 do change by a factor of 4. But we also notice that there's a change in the x values, right? And it looks like that 8 is getting smaller to a 4. So it looks like there is a factor of compression, maybe by a factor of 1/2, right? So I'm going to write this in words, right? So we have a vertical stretch factor of 4 is what we decided. And then just from looking at this, it looks like we have a horizontal compression by a factor of 1/2. And if we remember correctly, when we're trying to add that into the function, it would go somewhere here, right? So it's being added to the x, but it is the reciprocal of it. So it'd be f of 2x, not f of 1/2 x. So this is our function for g as a transformation of the function f. Alrighty, so number 40 says, write a formula that takes a function f and transforms it as follows. Reflect across the x-axis, horizontally compressed by a factor of 1/3, shifts right 4 units, and then shifts up 5 units. So we're just going to start with a generic f of x, right? So we know that f of x, we're going to reflect it across the x-axis first. So I'm gonna take this step by step. So we're going to do this step first, right? So we're going to reflect across the x-axis. So that means that we're going to have a negative, I have to draw this real quick. So say we have some function here, right? And we're reflecting across the x-axis. That's changing our y points, right? Because our x point here is the same as our x point here, but our y's are different. So that means that we will have a negative f of x. So that's step 1. And then now step 2, it says horizontally compressed by a factor of 1/3. So then this means that our x will be compressed by a factor of 1/3. So if we remember from the previous problem and just problems that we've talked about, when you're compressing by a factor of 1/3 horizontally, you're doing the reciprocal when you're putting it in the new formula. So now if we go from negative f of x, our new one will look like negative f of 3x, right? Because 3 is the reciprocal of 1/3. All right, and then the next one says shifts right 4 units. So if we're shifting right 4 units, so our function is f of 3x, and we're going to shift right, we're going to change the inside, right? And we need to make sure that we are changing only the x. So something like that, right? And then finally, it's our last one says shifts up 5 units. So if our function is f of 3 of x minus 4, our new function, if we're shifting up by 5 units, would be negative f of 3 x minus 4, all of that 5 added to it. So this is our brand new function. Alrighty, number 41 says, determine algebraically whether the function is even, odd, or neither. So I'm going to write a few things just to, if it's an even function, our f of negative x is going to be equal to our f of x. And if it's an odd function, our f of negative x will be equal to negative f of x. Okay. And then obviously neither, none of those two will apply. So let's test out our even first. So I will do this in green, and I will do this in blue, just to show the difference between where I'm testing. So we're going to test our even first, right? So we want f of negative x to equal f of x, right? So f of negative x is equal to square root, and I'm just taking what they gave me here, and I'm making all my x's negative x's, right, plus 1. So if I simplify that, that will give me negative x squared, which is just positive x squared, and then plus 1 doesn't change. So that is equal to f of x. So it looks like negative f of x is equal to positive f of x, which is exactly what we have here. And then just to check, make sure it's not also odd for whatever reason, let's check the odd chunk too. So f of negative x is equal to negative x squared plus 1, and again, that is equal to just x squared plus 1, which is equal to f of x, not the negative. If it was negative, we'd have a negative right here, but we do not. So we know that our function is even. Alrighty, and the last one says an even function f is decreasing and concave down in the first quadrant. What can you say about the function's behavior in the second quadrant? Okay, so just a few things to remember about even and odd functions besides algebraically. An even function, the reason this is true is because it is symmetric across the y-axis. And an odd function is symmetric across the origin, right? And I'm going to just state that the origin is 0, 0. So if we have an even function, let's just so keep that in mind. So our even function, that means this is going to hold true. So let's draw this out. So we have quadrants 1 and 2. And if you don't know, this is quadrant 1 and this is quadrant 2. Okay? So this is our positive y and this is our positive x. So in our first quadrant, it says the function is decreasing and concave down. So this can look like anything that's decreasing and concave down. I'm going to do something like this, right? Decreasing, concave down. So if we have an even function, right, that means it's going to be symmetric across the y-axis. So that means it's like if the y-axis is like a mirror, right? So then that means our new line on the other side looks something like this. I tried. So what does that mean? What is the behavior here? So we know the behavior here is increasing, and it's also concave down, right? So that's it. Thank you all for watching, and good luck on your exam.